In this problem, an object's thrown straight up in the air with an initial speed. What is the maximum height? So if we toss this with an original velocity, it's a positive going upward, 21.3 meters per second. We're going to reach that maximum height. At that moment, our velocity is going to equal 0. We stopped going up. We're about to start coming down. And we want to solve for that height, or we could label this as the displacement on the y-axis. And we know that gravity pulling downward has an acceleration of negative 9.8 meters per second squared. And so we know that the final velocity equals the original velocity squared plus 2 times acceleration times displacement. I'm picking this equation because I know the two velocities, original and final. I know the acceleration. I'm trying to solve for displacement. We will go ahead and change these symbols because we're talking about a falling object, or an object on the y-axis at least. So we'll change that A to G for acceleration due to gravity. We'll change the X to Y for the vertical axis. And we want to solve for y. So I'm going to subtract that original velocity squared. I'm going to divide everything by 2g to leave the y all by itself. And so plugging in those values, that final velocity of 0 squared is still 0, minus 21.3 meters per second squared, divided by 2 times a negative 9.8 meters per second squared. The units, you're going to square here on top. The meters are going to cancel on the bottom or reduce. The second squared are going to cancel. We're going to have meters remaining. So typing that into our calculator, I'm going to put a negative 21.3 squared divided by parentheses 2 times a negative 9.8. Those negatives are going to cancel. I'm going to show them to you here in my calculator, but they cancel out. And so we get a distance of 23.1 meters.